we know that the square root of -1 does not have a real answer. So we've been saying that it is not real because there was no number that we could multiply or square to, no real number that we could square to come up with a -1 answer. Everything would always square out to be positive. So we're going to define the imaginary unit. The imaginary unit, we're going to write it as an I, is the number whose square is -1. So we'll say that I squared is equal to -1. And as a result, the square root of -1 then is I. So we're going to use these two substitutions throughout this set of notes. So when we have the square root of -9, we're going to use the product rule and break it up and think of it as -1 times 9. So -9 is -1 times 9. The square root of -1 we learned is I, so we're going to replace this with an I. And then the square root of 9 is 3. And so I get a 3. I'll put the 3 in front, 3I. If I have the square root of -7, I'll do the same thing and make it the square root of -1 times the square root of 7, which is I. And this time when I don't know the square root of 7, so I'm going to have to leave it in the radical, I will put it in front of it, because if it was behind it, we don't really know if the i's back here or whether the i's inside the radical. So whenever you have a variable with a radical, you usually put it in the front. And then here I have a negative of the square root of -99. So we'll work the inside first. We'll make this a -1 times 99, which we're going to break up into 9 and 11. So this gives us a negative. We still have that negative. Square root of -1 is an I, and the square root of 9 is 3, so I'm going to write 3I. And then we have radical 11. So really the only hard thing about that was, how am I going to rearrange those variables or those numbers when I put those answers down? But there it is. This is what it's going to look like. So you try these next two variables, D and E, and see what you get. All right, so here's another change. We've been using the product rule up here. To multiply square roots of negative numbers, we cannot just use the product rule and multiply. But first, underline that, we must write each in terms of the imaginary unit I. So this is going to end right there, in terms of. So here's what I mean. When I have a -4 times a -9, I cannot say that that's going to be the square root of a positive 36. That answer would give me a positive 6. So notice what I'm telling you that you need to do. You need to write your -4 as 2 and then I, and your -9 as 3I. Then when you multiply it, you get 6, and then I times I is I squared. And of course, we learned up here that I squared is -1. So in place of the I squared, we put in -1, and we get -6. So you see, we get a totally different answer. We don't get a totally different answer. We get a different sign in front of our answer than if we had multiplied first and then taken the square root. So plan, star, you need to convert to i's first and then multiply. So here's some examples of that. We're going to simplify. So this was going to be I radical 2 times I radical 3. When I multiply it, I'm going to get I squared and then radical 6. And of course, I squared, I can substitute -1. So a negative square root of 6 for my answer. Here I have the square root of 8 times the square root of -2, so I'm going to do the square root of 8 times I radical 2. So when I multiply these, I get an I radical 16, and radical 16 is 4, so that's 4I. So you try D and E. Okay, so then now we're going to move into complex numbers. We just talked about the imaginary unit I. Complex numbers are going to use an I, and they're actually going to be sums of the real and imaginary numbers that can be expressed in the form a plus bi. So a complex number might look something like 5 plus 2i. That would just be a simple one, a real number plus an imaginary number. Notice that the complex numbers include not only just the complex, but inside of it you've got real numbers, which are made up of rational and irrational. So a rational number might be something like a 5 or a 1/2 or a 0.332. Those are all rational numbers. Irrational numbers are numbers that can't be expressed as a fraction, like square root of 2 pi, and maybe a decimal that has a repeating, no, that's not it either. Repeating bar is okay. So square root of 2 and pi are some examples. So a complex, an imaginary number then would be something like 5i or negative 1/3 I or 0.56i. So anything with an I in it, just a simple I expression, is going to be an imaginary number. And complex is made up of a mix of the two of them. So I might have something like a 1/2 plus, let's say we have down here 0.56i. Well, it's not the greatest because it mixes fractions and decimals, but that gives you an idea. So complex numbers include all of these. They include plain real numbers, rational and irrational. They include just imaginary numbers, and they include a mix of the two. So complex numbers are now our everything. Everything falls into the term complex numbers. So we will finish up these notes in our next video.